guys, how difficult. It's difficult to go live. Difficult, guys. I cannot overstate. It's difficult. It's not easy to go live at night. It's not, because there's so many factors that influence things. So yeah, I'm sorry, you guys probably were expecting me at 9, but no, it did not happen, did not materialize. So I'm going live now. Okay. So I hope you guys are well. I hope you're good. Let's get the likes up there, guys. Please, can we just get the likes up there if we can? And we are going to be looking at sequence and series. Okay. If you have missed sequence and series when I started it, I do encourage you to go and watch earlier videos of sequence and series, okay, on my YouTube channel, so that you can get caught up with what sort of like has been done before. Okay. Yeah. Otherwise, yeah, hello guys, it's really good to have some of you here. And yes, we are going to be actually picking up sequence and series, not really from the beginning, because the content has been covered, right? I went through in summary as to basically the content that it pertains to sequence and series. And as I said, if you missed that, then I encourage you to go to my YouTube channel and check out what you've missed, because I don't think it will be fair for me to repeat what has already been done. Okay, won't be fair at all. So yeah, I'm not really going to focus on that, not in the least. Okay, so I was just wanting to, yeah, I think this is appropriate, because on my YouTube channel, guys, this is what I have recently posted as far as content is concerned. So that grade 12 sequence and series where it says on Christmas Eve, yeah, that lesson there, basically I summarized the concepts that have to do with what we are covering in grade 12. Then further down is the grade 12 geometric sequence part 1. The reason why I did the grade 12 geometric sequence part 1 is because I noticed that in my uploads for grade 12 from last year, the geometric sequence video, the live lesson I did, was cut short. So I thought, let me just redo geometric sequence again so that we have that. Also on my YouTube channel, the playlist, you can go to the playlist and go to grade 12, the playlist for grade 12. There you'll find the live lessons I did last year. And those are good because I basically use Mind Action series. Okay, I use the Mind Action series textbook, and I use that to cover the content. All right. Go through some of the examples there, but also go through the exercises that are in the textbook. So that's why those videos are of value. Checking them out would be helpful to you. Okay, so I just thought, let me just share that with you as just general knowledge so that you guys know. And yeah, please guys, the link to the YouTube channel, link is in my bio. As I said, very raw videos, you know, not professional in the least bit, but the content I think is valuable. You can definitely check that out and watch it at your own time, your own pace, and not really under a live session setup. All right, let me just remove this now. All right, so guys, we're going to go through some questions, and as I would call them, exam type questions for sequence and series, because at least the content to some extent has been covered. I am going to go through the questions so that we can get familiarized with some of the exam type questions that we can get potentially exposed to, and this is to also facilitate how to think when we are approaching test type or exam type questions, right? And that's what I'll be doing in my live lessons today, possibly tomorrow, later on in the evening, and then for the next 3 days. Then I will be done with sequence and series, and I'll start functions with you guys thereafter, you know. So that's basically the order, and hopefully we'll go through functions, we'll cover the concept, we'll go through exercises, examples, then we'll do exam type questions, then we'll go ahead and do trigonometry, which is the last topic in term 1. So hopefully by the time you guys reopen, we will have covered some ground when it comes to the content for term 1, and we're just going to continue, guys, you know, and hopefully by that sequence of events we can actually have much of the content for grade 12 for maths covered, and then you guys will have the obligation of just ensuring that you practice on a daily basis so that you keep up to speed and also remember the things that you've covered. So let's look at the following questions that we will now be privileged to look at. All right. Okay, to start off, let's look at a question that maybe will kind of like start us out nicely. The following, as it says, sequence is given. Here is the sequence, guys: 2, -13, -26, -37. And the first question says, find the nth term in the terms of n. For how many marks? For 4 marks. So the following sequence is given. There it is. It's 2 minus 13 minus 26 and -37. Now in this, we are not told whether this is a quadratic, arithmetic, or geometric. So it is our responsibility then to figure out first what type of sequence we have. Right? And remember, if we want to check if it's arithmetic, we use the what? The constant difference. And we check as to, does the difference between 2 consecutive terms actually give us the same difference? If it does, then it means it's arithmetic. To check if it's geometric, we check as to whether the ratio for consecutive terms is that actually constant. Or if we want to check if it's a quadratic sequence, then what we should expect is that the second difference will be constant. So it can either be arithmetic, geometric, or quadratic. We are not told specifically, but guys, when you look at this, do we get a constant difference from the sequence? In other words, -13 minus plus 2. With minus 26 minus minus 13, do we get a constant difference? Can we say that this sequence is arithmetic? Okay. And surely, like, I think it would be very quick if we do this. Minus 13 minus 2 gives us negative 15. So the first difference for the first two terms gives us negative 15. And then if we check the consecutive terms, negative 26 plus minus 13, we get negative 39. So basically, there's no constant difference. So it's very clear that this is not arithmetic. So we are just going to abandon that idea of arithmetic. Could it be geometric? Possibly. Negative 13 divided by 2, that gives us negative 13 over 2, right? Negative 26 divided by negative 13, that gives us positive 2. So it seems like we need to abandon the idea that it is also geometric. Okay, is it quadratic? In other words, do we have a second constant difference? Well, let us see. 2, negative 13, negative 26, and negative 37. Mzala knowledge is saying it's quadratic. Okay, from grade 11, I'm sure you guys remember this. That you set up your sequence, you find your first difference, which we know the first difference is an arithmetic sequence. Minus 13 minus plus 2, that gives us negative 15. Negative 26 minus minus 13, that gives us negative 39. Minus 37 minus, this is negative 26 minus minus 13. Sorry, I said negative 39. It can't be negative 39. Remember, negative 26 minus minus 27, that's a negative times a negative is positive, so that gives us, yes, thank you so much, Precious. See the error that I nearly made there, and that is something to be mindful of. Okay, because remember, guys, when we say negative 13, we're subtracting 2. We are subtracting positive 2. So negative 13 minus plus 2 is negative 15. Negative 26, this is what we are writing down. Negative 26 minus minus 13. We are subtracting a negative 13. Does that make sense, guys? So that's why the answer is then negative 13. Same thing here. Negative 37 minus minus 26. Now we know, guys, that that's negative 36 plus, sorry, negative 37 plus 26, because the negative times the negative gives us a positive. So we know that gives us a what? A negative 11. Okay. So that is our first difference row. Our first difference row in a quadratic sequence gives us a linear pattern or an arithmetic sequence. Then we check out the second difference. Negative 15, negative 13, sorry, minus minus 15. We get a positive 2. Thank you, Queen. Negative 11 minus minus 13, we get another positive 2. So this is important, guys. Very, very important. Okay. I just want to bring to your attention something else here. 2 minus 15 gives us negative 13. Minus 13 minus 13 gives us negative 26. Minus 26 minus 11 gives us negative 37. So if we were to find the next few terms, we would basically write down the next constant difference, which we know if this is negative 15 and that is negative 13 and that is negative 11, the next term, we know that the first difference here, negative 11, negative 9. So that means negative 37 minus 9 would give us the next term. So to find the next term, guys, it's always nice to basically utilize our first difference rule in a quadratic sequence. I'm just bringing this to our attention. Why? Because sometimes these questions, instead of them asking us to find the nth term, they usually ask what is the next two terms in your original sequence. So when you have this set up, you can always use your first difference, because what are we doing to get the next term? We are taking 2, saying minus 15, we get the next term. So we are adding the first difference in order to get the next and the next term. Okay, but remember, guys, our goal here was to find the what? The nth term in the terms of n. So in the comment section, I love what I'm seeing here. Queen. So we know this is the second difference rule. That's where we know that the second difference is constant. So we use our expressions 2a, 3a plus b, and a plus b plus c. Our first expression 2a, we equate that with the second constant difference, right? 3a plus b, we equate that with the first term in the first difference. A plus b plus c, we equate that with the first term in the original sequence. I repeat, the expression 2a is equated with the constant difference. 3a plus b as an expression is equated with the first term in the first difference row. And then a plus b plus c is equated with the first term in the original sequence. Then all we do is we first deal with solving for a. In the comment section, I saw, for instance, that Queen already said to us that the value of a is equal to 1. Why? We divide by the coefficient of a, which is 2. What we do on the left, we do on the right. So if we divide by 2, that means we have a, and then division by 2 this side, because we're dividing by the coefficient of a, both left and right. Division by 2 leads to 1. Next, 3. This a, we know that a is equal to 1. We substitute in the place of a the value of 1. Then we add, there's the b, equated to negative 15. Then we solve for who? For b. So that means 3 plus b is equal to negative 15. Now we isolate the variable b. We transpose 13. Not 13, we transpose the 3. It's positive, moves over to the left, it becomes, to the right, it becomes negative. So b is equal to negative 18. So the value of b is negative 18. And we used our value of a that we had gotten, substituted it here so that we can find the variable b. Then we have a, which is 1. We have b, which is negative 18. Now we can basically take the a substituted here in the place of a, which is 1, plus we take the value of b, which is negative 18. And then lastly, c is what we are looking for, equated to the first term in the original sequence. Now we solve for who? For c. So we have 1, positive times negative is negative 18, plus c is equal to 2. 1 minus 18 is negative 17. We transpose negative 17, it becomes 17 plus 2 on the right hand side. What is 17 plus 2? Guys, 17 plus 2 is simply 19. So c is 19, as Mzala and Queen have confirmed in the comment section. So now we can write down Tn, the nth term of the quadratic sequence. We have a, we have B, we have C. So therefore, at the end of the day, final answer is what? In the place of A, in the place of B, and in the place of C, we can now write down the actual values. A is 1. 1 is there as a coefficient. Though we don't see it, it is there. Plus, in the place of B, we have negative 18. So of course, negative 18, positive times the negative, we are going to resolve that. Plus, the C value is positive 19. So our final answer for the nth term is n squared minus 18n plus 19. This is the nth term. So this is just a reminder, guys, of what we do whenever we are finding the nth term of a sequence, which we have found out is a quadratic sequence. Remember, we did not know what sequence this is until we checked. Does it have a constant difference? No. Does it have a constant ratio which makes it geometric? No. Do we perhaps have a second difference that is constant? Well, we write down the original sequence. We check if there's a first difference that is constant. Okay, there isn't, but there's only a first difference that is an arithmetic sequence. Then, of course, the second difference is the one that is constant. It is positive 2. And guys, all we do is we take the different expressions, 2a equated with the first term in the constant difference, 3a plus b equated with the first term in the arithmetic sequence, take a plus b plus c equated with the first term in the original sequence. And then from there, get a, get b, and get c. And then again, we go ahead and we substitute a, b, and c into an squared plus bn plus c. And then we solve. And voila. Okay. I think Mr. Setipa, teacher, get a life. Let the children enjoy festive season. Get a life first. Setipa, I think you have overstayed your time. Thank you so much for your comments, but we do not really need your negativity in the life. Goodbye. Goodbye. Okay, Ngwato, how did you have 3a? Now, where are you speaking? What are you talking about, Ngwato? Ngwato has the tendency of just saying something. What are you talking about? How did you have 3a? What do you mean by that, Ngwato? How did you have 3a? What 3a are you talking about? Ngwato, what grade are you in? Okay, because I think, what grade are you in? Are you in grade 11? Are you in grade 10? This is grade 12. Alright, and you asking me where did I get the 3a plus b is a bit concerning for me if you are in grade 12, if you are going to grade 12 next year. Okay, because remember, quadratic sequence is a concept covered in grade 11. So I just need to get in. Firstly, you need to just point me to what grade. Are we in grade 12? What? First question. So that I know how to move with you. And this is not to embarrass or to make shame, but it's you guys need to also really take into consideration what I keep on saying. Yeah, when you are in a certain grade and you have certain knowledge and understanding, finished long time ago, I'm stretching my mind again, 2010 matriculate, you're stretching your mind, so you are not in Wato. I think Wato is just here for interest's sake. All right, it would be better if you were saying to me, maybe you are intending to maybe rewrite, so it's just for enrichment. All right, so you are here for just personal enrichment. Not really, because remember Ngwato, I'm dealing with grade 11s, some of which are actually doing grade 12. Where does the 3a plus b come from? All right, now that's why I think you should spend the time and go to my previous live video that I did Go and watch it. Spend some time there. Okay. But it comes from these expressions. The 3a plus b is an expression found in the position where the first term of the first difference is located. Okay. How did I get even the a plus b plus c? So if we go to the general term of a quadratic sequence and you substitute in the place of t1, you substitute in the place of n1 and 1 there. That means you are going to get, for your original sequence, a plus b plus c. Okay. If you substitute 2, you are going to get 4a plus 2b plus c. If you substitute 3 for the third term, you'll get 9a plus 3b plus c. If you now find the first difference, in other words, you take this second term, you subtract this first term, you get this 3a plus b. Where is it located? It is an expression located in the place of the first term of the first difference. Okay. Also, when you get the third term subtracted with the second term, you get 5a plus b. When you subtract these two, this from that, this from that one, you get 2a. Okay. Okay, you get 2a. Oh, you also want to help your daughter. Okay, now that is, you see, now that's understandable. I was wondering, like, why do you just, because remember, I'm also working with people that are basically in grade 12 as well. Okay, if you have a daughter, then that's great. That means you're a good father. Then good for you. I'm happy. That's beautiful. So guys, so like I was saying, hopefully you're following along as I'm explaining what I'm explaining here. I know you probably were spending some time typing the message so that you can get to clarify to those who are asking you why you are doing what you are doing. So remember, this is T1, this is T2, and this is term 3. How did we get it? We substituted 1 in the place of n, and then if we substitute 1 here and there, we get a plus b plus c. We substitute 2 here, we get 4a plus 2b plus c. We substitute 3 there in the place of n, we get 9a plus 3b plus c. You subtract this minus that gives you 3a plus b. Why? 4a minus a gives you 3a. 2b minus b gives you b. C minus c, there's no c here. You take this minus that. 9a minus 4a gives you 5a. 3b minus 2b gives you b. C minus c gives you 0. So you are left with 5a plus b as an expression here. Then here, as your second difference, 5a plus b minus 3a plus b gives you 5a minus 3a gives you 2a. B minus b gives you 0. So you are left with 2a here. So the 2a expression is what we put in the place of the second difference constant. That's why we have 2a in that sequence. We had 2a being equal to 2. Then we had 3a plus b being equal to the term that was located here. We had a plus b plus c being equal to the first term in the original sequence. Okay, I hope that makes sense. Yeah. All right. So please, guys, yes, for 3a plus b is an expression for the first term for your first difference. A plus b plus c is the first term of the original sequence. 2a is the expression in the place of the second difference constant. So which is why we did what we did in this particular question. In the place of 2, we have 2a being equal to 2. In the place of negative 15, it's 3a plus b being equal to negative 15. In the place of 2, the first term in the original sequence, we write a plus b plus c, which is equal to 2. We first solve this 2a, we get a. We then move on to 3a plus b. Since we have a, we take that a, we substitute it in the place of a, we substitute 1, and then we solve for b. Then later on, we finish off. We have a, we have b, We substitute a and b, which is 1, b is negative 18, and we solve for c, and we get the value of c. After we are done, we are not done when we get a, b, and c. We need to go and substitute that into the original nth term, the general term of the quadratic sequence. We substitute a, which is 1, substitute b, which is negative 18, substitute c, which is positive 19, and then we simplify and get the nth term of the quadratic sequence. Okay. Hazel Brown, I love you too. I think you were saying I love you for what you are doing. Thank you so much. Thank you so much. I know you mean the opposite. I'm right. Thank you so much, Hazel Brown. You're the best. You're the best there ever was. Okay. All right. So I hope, guys, I hope we are good. Okay. I hope we are good. Next question. Between which two consecutive terms? The word that was supposed to be written here is the word consecutive. Between which two consecutive terms of the sequence will the first difference be 23? Again, between which two consecutive terms of the sequence will the first difference be 23? Okay. Between which two consecutive terms of the sequence will the first difference be 23? Now, there are two ways that I know of in which we can get the answer to this particular question. And there's one method that I prefer above the other one. Okay, and the one that I prefer above the other one is the following method. Listen to me and listen to me well. Remember, guys, we are asking what are the two terms of this sequence, which when we actually check those two terms will give us a first difference that is 23. So for instance, just bear with me here. This is like me saying, what are the two terms that will give me a first difference that is negative 15? So if I was to say, what are the two terms that will give me a first difference of negative 15? What are those two terms? It's term 1 and term 2. If I was to ask again, what are the two terms that will give me a first difference of negative 13? It's term 3 and term 2. If I asked again, which two consecutive terms will give me a first difference of negative 11? That is term 4 and term 3. So I hope you guys understand. So in other words, in this first difference row, there is a 23 somewhere up ahead. And the question is, there is a 23 up ahead as we go on. The question is, what are the two terms? Term what and term what will give you a first difference of 23? That's what they are asking in this question. All right. So the way that I like answering this question best, for me personally, for 3 marks, is the following way. So I will share with you both methods of how to do this particular question. And I want you to note, this question is saying between which two consecutive terms. So these terms need to be terms that follow each other. So for instance, the first difference, all right, of negative 15 is found by term 1 and term 2. All right. Okay. That's how we get the first difference of negative 15. Term 1 and term 2 give us that. So what we are going to do here is we are going to first take the nth term in this first difference. Remember, I said the first difference row gives us a what? An arithmetic sequence. Do you remember that I said that the first difference gives us an arithmetic sequence, or we can say a linear sequence. Linear and arithmetic, guys, means the same thing. In grade 10, you knew this sequence, negative 15, negative 13, negative 11. You knew it as a linear sequence. In grade 12, we just add the word, or we add the concept that we can also refer to a linear sequence as an arithmetic sequence. All in all, it's a sequence that has a first constant difference. That's what a arithmetic sequence or a linear sequence is in essence. Okay, so I can say Tn for my arithmetic sequence, I can say Tn is equal to what? 23. Tn is equal to what? 23. So I am going to find what is the nth term, what is the Tn of this sequence. And guys, the easy way of finding Tn is simply by using the general formula for finding the nth term for any arithmetic sequence. So if we look at this sequence, what is the first term? Remember, A means the first term, and the first term there is actually equal to negative 15. So we write in the place of A negative 15 plus n. Well, n is fine, it's general. Then D, what is D? D is the constant difference of which sequence? This sequence. What is the constant difference of the sequence? Guys, we know what the constant difference is. D is equal to 2. All right, because negative 13 minus 15 minus 15 gives us 2. Negative 11 minus 13 gives us 2. So the constant difference for this particular sequence is actually going to be 2. So we are going to write in the place of D 2. Then what is Tn? It's negative 15 plus. Now don't forget, this 2 here needs to be distributed into the bracket. Okay, all right, so what's positive 2 times n? It's 2n. What's positive 2 times negative 1? Negative 2. The answer that we get here is 2n minus 17. That is what Tn is going to be. Our general term of the first difference row is going to be 2n minus 17, or you can say negative 17 plus 2n. One is the same thing. All right, one in the same thing. Now what we are going to now do is we are going to take that Tn, which is 2n minus 17, and we are going to make it equal to the first difference, which is what? 23. Then we are going to solve for n. Why are we doing that? It's definitely December, and we are basically spending our December in style. Okay, while others spend their December in debauchery, Tina, we are spending our maths in style with maths. Okay, we'll see you as we spend our maths in December. We'll see you with our distinctions in March. Okay. We'll talk again when we celebrate our distinctions in March and June and September and November. So why are we saying 2n minus 17 is equal to 23? It's because we want to find the position. We want to find the position of this particular term. Okay, we're going to find the position. We want to find the position of this particular term 23 in the first difference row, and that's going to help us out with something. So here we go. 2n minus 17 is equal to 23. So let's solve for n. We transpose the Mr. negative 17, he becomes a positive 17. 2n is equal to 40, and then Zala knowledge, as you have said, our value of n is 20. All right, so what does that mean? In other words, it means, and I need us to lock in so that we can appreciate what is happening here. All right. This thing was asking between which two terms of the sequence will the first difference be 23? Okay, so think about it. 2 and negative 13, they are the terms that give us the first difference, which is negative 15. What is that? It's term 1 and term 2. Term 1 and term 2 give us term 1 of the first difference row. Term 3 and term 2, the difference between these two gives us term 2 of the first difference row. Term 3 and term 4 gives us term 3 of the first difference row. Okay. Now, this is term what? This 23 is term 20. Are we together? It is term 20. Mzala knowledge, I love what you are thinking. If it is term 20 of the first difference row, that is 23, what are the two terms that were giving me this term 23? This term 20. It is obviously going to be term 19 and term 20 of the original sequence. No, I'm kidding, guys. It can't be term 21. It can't be term 19 and 20. It has to be term 20, yes. And term what? 21. Okay. Look at pressures there. Let us compare. Mzala knowledge says term 19 and 20, whereas pressures is saying term 20 and 21. Okay. Remember, guys, it was term 1 of the first difference that is being given by term 1 and term 2. Term 2 is given by who? Term 2 and term 3. Term 3 is given by who? Term 3 and term 4. So obviously, if then the sequence in our first difference is term 20, in other words, term 20 is equal to the 23, then it means that the two terms in the original sequence that give us term 20 have to be what? Term 20 and term 21. All right, I love the collaboration there in the comment section. I appreciate your humility, Mzala. Because true knowledge is found in humility. So I really appreciate your humility there and the appreciating the correction there from Precious. Okay. All right. Are we understanding this, guys? Okay. So the best way to deal with questions like this, between which two consecutive terms of the sequence will the first difference be? We are given the value of the first difference term. Okay. We are given that value. It's 23. So our objective is to first find the nth term of the first difference row. We know that the first difference row is an arithmetic sequence, or in other words, it's a linear sequence. In grade 11 already, we would know that, this sequence in actual fact is a linear sequence. In grade 12, we are just sort of like also availing our minds to the idea that, linear sequence also means arithmetic sequence. Okay, and then all we simply do, we take that value of the term, which is 23, we equate it to Tn. Why? So that we can find the position of this term. But we need to know the general term first of that arithmetic sequence. So find the nth term first if we don't have it. If we had it initially, we would just simply take that nth term and equate it to 23 and find n. But here, we first had to find Tn, which we've successfully done using our understanding of arithmetic sequence. A plus brackets n minus 1 into d. A is negative 15. D is the constant difference of that sequence, which is 2. We distribute the 2. 2 times n is 2n. 2 times negative 1 is negative 2. We add the like terms. We get 2n minus 17, which is the nth term. Then we take that nth term. We equate it to 23. We solve for n. We get n that is 20. That n that is 20, we know that the position of the term, which is the value of the term, which is 23, is term 20. But that term 20, which two terms that are consecutive in the original sequence form this first difference, which is 23, which is term 20? We know that it is term 20 and term 21. Those are the two consecutive terms, all right, that basically form the first difference, which is 23. Okay. Yes, if we were told that the position of the term is term 15, had we found that n is equal to 15, the position is 15, then it would mean that the two consecutive terms that basically form that first difference, it would be term 15 and term 16. You get the point. When there's life in you, definitely life in you. All right, that comment is an indication that you understand the concept. If it was term 17, then we know it would be term 17 and term 18. If it was term 12, then we know it's term 12 and term 13. If it was term 27, we know it's term 27 and term 28. If it was term 102, we know it's term 102 and term 103. All right. So for the original sequence, it's that position of the term, the same position of the term, and the later or the consecutive term that follows. Okay. Here they didn't ask for the value of the terms, but they asked simply by which two consecutive terms of the sequence will the first difference be 23. Okay. So if we wanted to find the actual value of those two terms, then we could take term 20 and substitute it where? Into the general quadratic term, so that we can find the actual value of the term in that position, and then take T21, substitute it into the original quadratic, so that we can find the value of the term if they had asked for the value of the term. Okay. All right, I hope that's clear for us, guys. I hope that's clear. 3 good marks, really and truly 3 good marks that we can attain. Take the nth term of the first difference, find the nth term first, equate it to 23, get the position, and then from there extrapolate the two terms and their position, and that's that. Okay, let's move on to the next question. The next question says, which term in the sequence? So guys, please take note of this question that I've just done and the manner in which we did it. Please take note of it, guys. Take note, take note, take note. All right. Moving right along. Which term in the sequence will have the smallest value? Which term in the sequence will have the smallest value? Which term in the sequence? Now I want to check if people that are in grade 12 still remember this concept here. What is this talking about? The smallest value. There is a synonymous word that I want to see. Oh, very good. Precious. You are very precious, you. Smallest value equates to minimum value. And the minute you hear this word minimum value, what does that make you think about specifically? I'm hoping our minds are really working here. Smallest value means lowest value, but also means minimum value. Okay. Thank you, Precious. Turning point. Ha. I Precious, you when I can see you are still with your content for grade what? For grade 12, grade 11. Your grade 11 content is still intact. Okay. Right? Guys, smallest value. Now, is this question actually legitimate? Okay. Are they correct in asking you and me about this question? To say smallest value rather than saying highest value. Are they correct in saying smallest value? Can they ask us what the highest value is or the maximum value is? Could they ask us that? Or is it only legit that they ask us about the smallest or the minimum value for this particular quadratic expression? Okay, Precious is saying yes, it's legit for them to ask us this question. Okay, Luanli is also saying it's legit. Okay, and yes, it is, guys. It is. Okay, and Mudro is further explaining why. Guys, I just want to, kind of bring this relationship into focus. When we talk about number patterns, okay, the quadratic sequence can be likened, and I use the word likened to the parabola because it's not a parabola, but it can be likened to a parabola because the nature of the expression is quadratic. And by quadratic, we mean we could compare it to a quadratic function, which is our parabola. And we must remember, guys, if the coefficient of the square term is positive, what does that mean about your parabola? It means the parabola is it has a shape of smile. Are you with me, guys? Even though we know that a sequence is not a continuous thing, a sequence is discrete. Okay, it's not continuous, so it's not going to be a connection. But the shape, guys, is supposed to be a happy face, a smiling face. So that means there is a low value, your bottom value, concave up graph. Very good, Precious. So we have what we call a minimum, or your smallest. That is why Luandle and Precious were saying, when I asked the question, is it legit that they are asking us this question? Which term in the sequence will have the smallest value or minimum value? So when Luandle and Precious say yes, the question is legit. It's legit because by smallest value for this type of quadratic number pattern, where the coefficient of the square term for n is positive, we do expect to have a what? A concave up sort of like shape, if you will, for your sequence. Therefore, that means we have a what? A minimum value, not a maximum. We have a minimum, or what we would call your smallest, or sometimes they will say your lowest value. Okay, these are synonymous words that they can use when they are asking the question in the exam. So let's look at the question again. It says, which term in the sequence will have the smallest value? Okay, so listen up then. Tn is like y. N, all right, forever in the first quadrant, as has been explained by Ngwato. Ngwato, I love what you said, because for n we can't ever say n. N we know means position, and our position can either be 1, 2, 3. Position can never be negative. So that's why Ngwato in the comment section is saying first quadrant. Okay, I love this. You guys are amazing. I truly believe like you guys are like phenomenal. Ngwato, I think you'll be doing a phenomenal job with your daughter, that's for sure. Okay. So we're dealing with n specifically There's no ways we are going to have this quadrant, and there's no ways we are going to be having this quadrant. Yeah, sorry. There's no ways we are going to be having, the second quadrant and the third quadrant, in other words. But definitely we will have the first and the fourth quadrant very much active, no doubt. Okay, very much active, no doubt, because y represents Tn, which is the value of the term. N represents our natural numbers, which are the position. Okay, 1, 2, 3. That's why we say n is an element of what? Of natural numbers. Remember, guys, when we say n is an element of natural numbers, we are saying n should only be a natural number. And natural numbers, we know that these are numbers that start at 1, they increase by 1 all the way to infinity. Make sense, guys? So that's why first and fourth quadrant, when we are talking about a sequence, we can only be dealing with first and fourth quadrant alone, not second. Second and third are out. First and fourth quadrant. This is the first quadrant, this is the fourth quadrant. We can have the pattern showcased in the first and the fourth quadrant alone. Okay, are we together, guys? We can't have it in the second, because n is not an element of what? Of integers. Okay, Tn on the other hand is an element. Tn, when we are talking about the value of the term, we can say Tn is an element of real numbers. Okay, because the value of the term can be any real number. Any real number. And by real numbers, we include both rational and irrational numbers. Rational and irrational. So that's why here it can be positive or negative values. Okay, we include the negative values because a value of a term can either be positive, it can be negative. As you can see here, the value of this term is negative 13. Okay. Hey, Mashama says the value indeed is CC1, but our minds are very much open. You see? And our minds are more powerful than an institution that is closed. You see, that is the power of the mind. So that's why we are pushing. But yeah, you can move on to the next live, dear lady, and then Tina will see you with our distinctions after term 1. Okay, so 1, 2, 3. Okay, n element of natural numbers, but your Tn is an element of real numbers. Okay, does that make sense? So n, your position, will always be a natural number. What do we mean by natural numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, nothing else. Then for your Tn, a value of a term can be any real number. All right, so that's why we say we deal with the first and the fourth quadrant specifically. If we were to actually draw this particular sequence. So for instance, look, term 1, what term 1 here is 2. So let's say we had 1, 2, let's say that's 2 there. That's term 1. Okay, so we put the dot there. Term 2 is negative 13. Guys, negative 2 is negative 13. Let's say negative 13 is here somewhere. Does that make sense? Negative 13 for Tn is here somewhere. Okay, let's say negative 13 is here somewhere. You guys get the point. Term 3 is negative 26. So I go to 3, I locate negative 26. That negative 26 will be further down here somewhere. So you guys can see the shape already. You see, we are not going to connect these dots because this is a pattern. But the shape you will see is a shape that is like this, to show that indeed when n has a coefficient that is positive, it's concave up, right? But the dots will never connect because, like I said, a pattern is discrete, it is not continuous. These two words are very important, guys. A pattern is discrete, whereas a function is continuous. Two words that you guys should have been exposed to when you first were introduced to functions in grade 9. discrete, continuous. Okay, a function is continuous, but a number pattern is discrete. Okay, so when we talk about minimum or minimum value, okay, sorry guys, I know I went off on a tangent, but I hope you guys appreciate the additional information because it helps you to have a deeper understanding of what you are doing. You're not just answering questions for the sake of answering questions. Your questions can be asked very differently, but when you have an understanding generally of what you are dealing with, then it helps with attempting any other question that is outside of the box that you can get asked. Okay. Which term in the sequence will have the smallest value? So if you remember guys, when we talk about minimum, smallest or lowest value, maximum, highest or greatest value, then there is this formula. Okay, in functions we used this formula to find the x value of the turning point. In number patterns we can use the very same formula, but we are not going to say x. Remember guys, I said your x values are replaced with n, the natural number. So we're going to say n is equal to minus b over 2a. Does that make sense guys? N is equal to minus b over 2a. Which term? Definitely when we find n, we are going to know which term in the sequence will have the smallest value. It's only 2 marks, so it's only appropriate that we say n is equal to minus b over 2a. Where is the b? Ooh, there is the b. So we say n is equal to, in the place of b, so keep the negative sign because it's in the formula. B is negative 18 over 2. Our a, coefficient of n squared, is 1. Then we simplify this. Negative 18 negative 18 minus, sorry guys, that's positive because remember there was a negative sign. B is negative 18, so a negative times a negative is positive, so it's 18 divided by 2, which is 9. Okay, so what does that mean guys? Term 9. Which term in the sequence will have the smallest value? It's term 9. Okay, remember guys, say opulence, you are right. We could use the completing the square method. We complete the square of the expression. But what will that do? One, I can tell you this. It will be long. It will be time wasting. And if you want to be spending less time answering a question, you would rather use this formula and get straight to the point. Guys, let us try and utilize quick methods, because I tell you this, learners are complaining every single year about the inability of finishing question papers. Why? Because they use long methods sometimes. If you can complete the square, and you can complete the square in the same time in which you can do this, then please guys, by all means, go ahead, complete the square of the expression. But I would not encourage it, okay, personally. You have a formula guys. We are going to learn, all right, later on we are going to do calculus. When we do calculus, there is another shorter method that we can utilize using calculus. Okay, there is even another shorter method, even better than completing the square of the expression. When we use calculus, okay, yeah, we use the first derivative of the actual expression and then we get the value of n. All right, that's another way to find the smallest value. Okay, which term in the sequence will have term 9 will give us the smallest value. If you want to actually find out what that small value is, take T9. That 9 you can substitute there in the place of n. You will get the actual value. Okay, all we wanted, Tina, is which term. We know it's term what? Term 9. But if you want to figure out what is the actual value of term 9, take the 9, which is n, substitute it into the original equation, and then you will be able to find what that value is. Okay, the specific value. Okay. Is there any questions for me? Okay, so this was just a question on quadratic sequence that just reminded us, and it reminded us, okay, of what is to be. Can such questions be asked in functions? If the question is being asked in functions, the way that it is usually asked is when they are asking us if they give us the quadratic function. Remember, now we are talking about a function. We are no longer talking about we are no longer talking about a sequence. Remember, guys, quadratic function, this would be a quadratic function, x squared minus 18x plus 19. Remember, that is not a discrete, but it is a continuous parabola. The type of question that could be asked, which is similar to this, but under functions now, would be them asking us what is the coordinates. What are the coordinates of the turning point? What are the coordinates of the turning point? If they ask us for the coordinates of the turning point, we know that we can use x is equal to minus b over 2a in this and find the x value of the turning point, which would obviously be 9. Okay, x would be equal to 9. If they ask us for the value of x by which the function is a minimum, remember, the value of x for which the function will be at its minimum. If they're asking us what value of x will the function be at a minimum, then we use x is equal to minus b over 2a to find the value of x that will give us that minimum. Okay. Yes, men x BL, we can definitely complete the square, but as I said to the learners, completing the square, if you are well versed in completing the square and you know that you will spend less time completing the square of the quadratic expression, go ahead, use it. But now we are also trying to fight we are also in the battle of not only wanting to be accurate, but also complete the question paper. So this is simpler than completing the square of the expression, because some learners may run into certain difficulties when completing the square of the expression. And I'm not saying that completing the square of the expression is not correct. You can go ahead and do that, but it is better to just use n is equal to minus b over 2a, or x is equal to minus b over 2a if it's a function. If it's a quadratic sequence, n is equal to minus b over 2a. Get the value of n, and then you substitute it back into the original to get the corresponding value of the term if it is a sequence, or the corresponding y value if it is a quadratic function, so that you have the coordinates of the turning point by so doing. Precious is also exposing us to another formula that if you want to find the y value of the turning point, you can use 4ac minus b squared over 4a. That's also 100% fine. That's another formula that we use if we want the corresponding y value. Okay, very much correct. Or if you want to find Tn, in other words, the value of the actual value of the term, you can use this formula, get Tn. So please, guys, for the function, this is what we know. X is equal to minus b over 2a and y is equal to 4ac minus b squared over 4a. For a sequence that is quadratic, n is equal to minus b over 2a is how you find the position, and the value of the term, you use 4ac minus b squared over 4a. Really up to you. Or you can take the n and substitute it back into the original. You'll still get the same value of the term. So these are just, ways in which we can get answers. All right, guys, I am going to move on now. I think quadratic sequence, we have spent enough time wheeling and dealing with quadratic sequence, and I'm sure you guys now are like, yeah, I can feel the fire, I can feel the heat. Okay, I know you can feel the fire, you can feel the heat. All right, so let's move on to another question. Okay, I hope you guys are ready for this. Okay, just to get somewhat of a variety here of questions. Okay, let's look at this now. The following series is given. What do we have now? We have a series, right? 6 plus 3 plus 20 plus 27 plus ... plus. And then it says find the nth term in terms of n for 3 marks. Okay, so once again, are we told the kind of series we have here? Are we told what series it is? So this is not a sequence, but it is a series. What is the difference between a sequence and a series? A sequence is merely a list of ordered terms. A series is a summation and addition of those particular terms. It's still a sequence, but it's a summation of those terms in the sequence. That's what a series is, right? I just want to see if I can something here that maybe can I don't know if this, let me just see if I yeah, so Boypilo, just be careful there. That formula that Precious gave of 4ac minus b squared over 4a, that is designed to help us find not the term, but the value of the term. Okay, if we were talking about the coordinates of a turning point, then we are talking about the y value, not the x value. So when you use that 4ac minus b squared over 4a, you are not using it to find the value of n, okay, or the position. You are using it to find the actual value of the term that is occupying the 9th position. Okay, so just note the difference between those. Not the same thing. Okay, I hope that kind of clarifies some things for you. Okay, let's come back here. Following series is given: 6 plus 3 plus 20 plus 27 plus ... Find the nth term in terms of n. Find the what? The nth term. So we need to first establish, is it an arithmetic series? Okay, because remember, a series still, if it is arithmetic, the constant difference should be popping. T2 minus T1 should be the same thing as T3 minus T2 if it is what? Arithmetic. If it is a geometric series, then still the constant ratio, okay, should be yielding the same answer. T2 divided by T1 should be giving me the same thing as T3 divided by T2. And then lastly, so those are the two series, guys, arithmetic or geometric. So which one is it? 6 plus 3 plus 20 plus 27. What is it giving? What type of series is this? All right. And the way that we find the nth term of a sequence is the same way that we find the nth term of a series. There's no difference between how we find the nth term of a series and the nth term of a sequence. Okay, and then of course we could have it as quadratic as well. I mean, that's another interesting thing, I wrote. We could have that situation. Oh, sorry guys, I made a mistake here. 6 plus 13. I knew I made a bit of a mistake there. Okay, 6 plus 13 plus 20 plus 27. Sorry, my bad guys. Okay, when I wrote this down, I wrote it down incorrectly, the sequence. Sorry. Okay, so arithmetic or geometric series. Okay, so which one is it? 6 plus 13 plus 20 plus 27 plus ... plus, and so it goes. So the question is, find the nth term, okay, in terms of n. Okay, thank you, Mzala. Mzala is with us there. Mzala has acknowledged that it's an arithmetic series. So if that is the case, then what does it mean for us, guys? We want the nth term. We just want Tn. So what do? We write down our generalities there. Okay, Tn is equal to a plus n minus 1 into d. So the minute we are able to establish what type of series it is, it makes it easy then to know what formula to be using or what formula to identify. Then what do we want here? We want a and we want d. Once we have a and d, then the nth term is easy. Okay, our a value, first term, is 6. All right, and then what is d? T2 minus T1, which is further supported by T3 minus T2. What is that giving us, guys? 7. Thank you. Very true. So D is equal to positive 7. You guys have said it correctly. And all we do is we do the substitution. Okay, now we just do the substitution. So we identify the type of sequence first, or series, that we have using our checking devices. We check difference, we check ratio. If there's constancy in difference, then it means it's an arithmetic series. If there's constancy in ratio, then we know it's a geometric. But in this case, it's not a geometric, it's a arithmetic. So we now substitute 6 plus. Now the n minus 1 is there. Okay, guys, I like this d here. I prefer to place the d before the bracket rather than after. Why is that the case? Sometimes learners tend to forget that with the minute the value is placed after, you still need to distribute. And what are you distributing in actual fact? The sign of this is plus, so you are distributing a positive 7 into the bracket. So I usually love rather to rewrite this formula as a plus d. The d, I write it this side, and then n minus 1, so that I don't forget to distribute the constant difference, because sometimes learners tend to forget to distribute the constant difference. So 6 plus 7n minus 7, like terms, 7n minus 1. This here is Tn. This is the nth term in terms of n. Did we all get it? Or is there maybe an error that I made that you guys want to correct? Maybe something I did not do correctly? Okay, thank you, Boypilo. Boypilo has confirmed. If Boypilo says it's fine, then you must know it's 100%. We all got it. Oh my goodness. Are you guys trying hard to stay up? Yeah, it's after 12. Me, guys, I'm so energized, it's not even funny. I took a bit of a nap, so I think I'm going to be going on for quite a while. So if you guys sleep, it's fine. Remember, you always have the YouTube channel. You can always go and watch. I'll try and upload this as soon as possible after I'm done with the live. Okay, yeah, so if you sleep, it's fine. Don't feel too bad. Okay, next question. Find the sum of the first 20 terms. Find the sum of the first 20 terms. Mudro, it's maths is a game. You can just, the link is in my bio for the YouTube channel, guys. The link is in my bio. So if you go to the main page, you will see the link. The only link that's there is the YouTube channel link. You click on the YouTube channel link, go there, guys. You subscribe, please. I need the subscriptions, the subscribers. Right? Channel is still young. There's nothing that has happened with it so far. It's still just the channel. Yeah, seeing as though people can't really support me, it would be nice if you guys support me by actually going to the YouTube channel and watching the actual videos and commenting on the comment section, so that these videos can be pushed to the FYP page. That's how you can support me without actually supporting me the way that, you know, would normally be nice to support. For instance, the live lessons, I understand most of you can't give gifts, which is fine. I don't mind, but it would be nice if you can support me in that way. You go to the YouTube channel, you subscribe, you make sure you comment, yes, even if like you don't feel like there's a need to comment, just comment, say something on the in the comment section about the video. That's how you help me. At least, these are small ways in which you help. The views as well. Okay, views tend to be very low, and I know. Okay, but yeah, you guys help me out with those things. Find the sum of the first 20 terms. So what is the sum? How do we go about finding the sum of the first 20 terms? What did we learn in previous live lessons that helps us with determining the sum? And remember, this is a series, an arithmetic one. So, and we are told specifically find the sum of the first 20 terms. Right? So what formula do we have that we can use? Sn is equal to, so what's beautiful is that the formula sheet will be there. Okay, there is this formula that we can use. Okay, this means sum of n terms. Okay, this n means number of terms, the sum of the, so if you write 20 here, you say S20, it means it's the sum of the first 20 terms. That's what this n means. It's number of terms. The n means number of terms. So if you write 5 in the place of n, you are saying the sum of the first 5 terms. If you write 10 here, you are writing the sum of the first 10 terms. If you write 20 here, you are saying the sum of the first 20 terms. So yes, guys, please, this is the formula. But when it's arithmetic series, guys, this is the formula we use for arithmetic series. If it was geometric, there's a different formula, but this is the formula for arithmetic. Okay, yeah. And all we need to actually utilize this formula is we need the value of n, which in this case we know is 20, because n means number of terms. We want the sum of the first 20 terms. We need a we've already established that for this series the first term is 6, and then lastly we need d we've already established, it is 7, and then all we do is we do a substitution, and then we use our calculator, we get the answer, and that's that. Okay, so S20, siphumelele mtshali, sivalile eskila. It's true, but our minds are open. Asivalwanga engqondweni, yeah. So n is 20, but thanks for the information. I think we all know that schools are closed, the governmental institutions, they are closed, but our minds, they are forever opened, because we are not closed-minded. So S20, n is 20, S20 is equal to 20 over 2 into 2. A is 6 plus, remember now this idea of d, 7 into n minus 1. Okay, then straightforward, 20 divided by 2 is 10, that is 12. 7n minus 7. We distribute the 7 that is positive inside the bracket. 10 into, oh sorry, let's not forget, we forgot to put the 20 here, guys. I'm sorry about that. You see what I did here? Forgot to put the 20 minus 1, and I complicated life when I shouldn't have. Okay, 20 minus 1 is 19, and then I have 7 times 19. Okay, so you have the 12 there. But like I said, guys, you could have put this in a calculator a long time ago and gotten the answer without having to do all of this. Okay, yeah. So once you substitute there, guys, you could just put all of this in your calculator, literally everything, and just get the answer. So God's grace has already helped us out there with precious. Our answer for the sum of the first 20 terms is 1450. So if we add the first 20 terms of this particular series, we get 1450. That's what we get when we add, okay, the first 20 terms of which series? This one. Okay, there are more terms obviously, and until we get to the 20th term, we can actually then find what is the sum of the first 20 terms in that way. Okay, so that's the formula we use, guys. Sn is equal to n over 2 into brackets 2a plus brackets n minus 1, close brackets, you write the d, then you close the bracket for the entire expression after n over 2. Okay, and there we have it. Okay, really not necessary for us to be doing all of this. We could just plug in the 20, grab the calculator, punch everything in, like literally say like 20 over 2. We open the bracket there. As you have it there, you have the 2 and the 6. You close the bracket there. You say plus. You have the 7 into, you have the 20 minus 1. You close the bracket. You close it twice because you know most you want to make sure that everything is as you wrote it down. You press equal. Voila. You see? So there's no need for all of these gimmicks because you don't have time. So you write the formula. You substitute all the values a, n, and d, then you use your calculator. After this step, you use your calculator, you just write the answer immediately. Okay, then that way you don't waste time. Remember, this after all is a 2-mark question. You don't want to be spending more than a minute for 2 marks. No, especially for this 2 marks. This is simple identification of formula, substitution, answer. Identification of formula, substitution, calculator, answer. You see? And then 1 minute, you are done. You move on to the next question so that you save time. Okay, look at the next question. Write the sum of the first 20 terms in sigma notation. Now this should be interesting. For how many marks? For 2 marks. What are they saying? Write the sum of the first 20 terms in sigma notation. Okay, are we ready for this question? Okay, do we still remember the components of sigma? Remember, there is our sigma symbol. All right, that's very important. Here at the top, and then here at the bottom. Okay, so let's choose any variable that is not x. Let's just think of any variable. You guys can tell me which variable you would like. There are 26 letters in the alphabet. Let's choose a variable that I can actually write down here. Okay, a, fine, we'll write a. Thank you, Sir Opulence. Let's just use a. So if I'm going to say a is equal to 1, then remember they are saying I need to write the sum of the first 20 terms. So here at the top I'm going to write 20. Okay, this is the number that I substitute in the expression, the nth term, okay, for my first substitution, and then this is the one that I substitute last. Okay, this is the one that I substitute last. Okay, then Here, I need the general term of the sequence. All I need here is the general term of the sequence. I already have it. Tn is equal to 7n minus 1. So I can just say 7a minus 1. Why am I writing a? Because you chose the variable a. A is equal to 1. So because we said a, that means that here in our nth term that we write here as the expression, we are going to write 7a minus 1. Okay, right? So that's all you need for sigma. You just need the nth term of the series that you have. You need your beginning, who you are going to substitute first, and then who you are going to substitute last. That's what you need, guys. Okay, that's what you need. That is sigma in summary. Okay, I don't know if people have any questions. Mzala says sigma is confusing. Sigma notation is confusing. I don't know even after you have listened to this simplistic short explanation, if you are still confused. If you are, let me know. If you are not, let me know. If there's something you want to clarify, let me know. I am now available to field any question you may have. Okay. So can you do one where the beginning is not 1? Okay, 2, 6. Okay, this here 7a minus 1 is simply the what? The nth term. The what? The nth term. Okay, remember I asked you guys for the letter. Okay, maybe if we would have chosen n is equal to 1, then we would have had 7a minus 7n in the place of a minus 1. Maybe that would have been more familiar than the 20 at the top. Okay, but guys, what you write here is the nth term, the general term. So you must first find out what is the general term of the given sequence. What is the what? The general term of the what? Of the given sequence. Are you with me? You must find out what the general term of the given sequence. What is the general term of the given sequence? That's what you want. Okay, so 2, 6. Okay, where does 7a minus 1 comes from? It comes from in the given sequence. Your question that you need to answer for yourself: what is the general term of this particular series? So we did find out what the general term of the series is. We first found out that this is an arithmetic series. Why? Because we don't have a constant ratio, but we have a constant difference. 13 minus 6 gives us 7, and 20 minus 13 gives us 7, and 27 minus 20 gives us 7. So there's a constant difference. What type of series is this? It's arithmetic. If it's arithmetic, what is the general term that I use to find the actual nth term of this specific sequence? It's going to be Tn is equal to a plus brackets n minus 1 brackets d. What is a? My first term. What is d? My constant difference, which is 7, as I have explained. We then substitute a, we substitute d, we distribute, we add like terms, we get the nth term. So Tn is equal to 7n minus 1. So what belongs next to the sigma sign here is the nth term. Okay, so whatever we write here is always the nth term of the given series. Okay, it is always the nth term of the given series. Because we have a first term for this given series, we are going to start at 1. What is the first term of the given series? It is 6. All right, so our substitution will lead to the first term of the particular series that we have. For this particular series, the first term is 6, and we specifically want to write down the sum of the first 20 terms in sigma notation. But of which series, guys? Of this series. So now if you're going to start at 1, what is 7 times the 1? You substitute in the place of a, you substitute 1. What's 7 times 1? It's 7. What's 7 minus 1? It is the 6, which is the first term of the series. You substitute a consecutive value. After 1, you substitute 2. What's 7 times 2? It's 14. What's 14 minus 1? It's 13, the next term. You consider the next consecutive value of a, which is 3. What's 7 times 3? 21. What's 21 minus 1? It's 20. There it is. You see? Up until what? The last, which is what? 20. Why did we write 20? Because we asked for sigma when we write the what? The sum of the first 20 terms. They wanted the first 20. Had they said the first 19, we would have said a is equal to 1, and then at the top we would have written 19. Had they said write the sum of the first 12 terms, then of course we would have said a is equal to 1, and then here we would have written 12. Okay, please get the point, guys. All right, yeah. So here, what we substitute first to get the first term, what we substitute last. Because here, if they say sum of the first 20, then obviously it is 20 that we substitute last for this given sigma that we have there. So in terms of a, if you use a, then it means that your general term needs to be in terms of a. If you write n, then it means your general term needs to be in terms of n. Had you written k, then your general term would have had to be in terms of k. P in terms of p. L in terms of L, T in terms of T. Okay. I feel like you guys, I'm explaining the stuff, and yeah, hopefully it is not falling by the wayside. Right? Hopefully it is not falling by the wayside. It's hitting home. Okay, it's hitting home. I wish that it hits home. Let's look at this question. Calculate the value of n if. What do they want? The value of n. If what, guys? If what? If k is equal to 3. All right. So in order to get the first term of this particular series, we substitute 3 first. Okay? Substitute 3 first. Right. But what do they want? They want n. What is n? That value that we substitute last. If this thing will give us a sum of 189. Okay, so here we are being specifically told, if you take 3, you substitute here. What type of series? If I ask you guys what type of series is this based on what you see in your nth term, this nth term is giving what type of series? Let's see if you guys you kind of have an idea of what type of series would this be. What type of series would this be? K minus 1 is giving what? What is it giving? Is it geometric? Is it arithmetic? Thank you, Anyi. Anyi is spot on. It's arithmetic, guys. Why is it arithmetic? Because 1, we don't have an exponent that is a variable. Rather, the variable is a base. All right. And if the variable is a base and there's no exponent that is numerical, that is more than 1, then it must mean that this is linear. Okay. It's linear, which gives arithmetic. So what do we then do here? We want to calculate the value of n. The sum is 189. So the summation of all of this should give us 189. We already have the sum of the entire series. Okay, but what do we want? We want to find out what is the last term. All right. What is the value that we substitute in order to get the last term? So here's what we do step by step. Step number 1. Let us first find the terms of the series by substituting 3 and the consecutive values after 3 for at least 3 terms. So if I take 3 and I substitute it here, what do I get? 3 minus 1, 4 minus 1, right? Remember, it's a series, so I'm going to write plus 5 minus 1. So at least for the first 3 terms, I have 2 plus 3 plus 4. Okay. Yeah. And remember, all of this is equal to 189, all in all. Okay. So first 3 terms, I have first 3 terms I have. Now 2, the second part, is me being able to find what is the value of n, the number of terms. We need to find out what the number of terms is. In order to do that, we say n minus 3. We say top minus bottom, and then we add 1. What does that give us, guys? It gives us n minus 2. So number of terms in terms of n is n minus 2. This is giving number of terms in terms of n. Number of terms in terms of n. Okay, because remember, at the end of the day, what do they want? They want us to calculate the value of n if n at the top, which is, we know, is what we substitute to get the last term in the series. 3 at the bottom, it's what we substitute to get the first term in the series. Okay, so usually we find the number of terms in a given sigma by taking the top number minus the bottom number, and then we add 1. This is a key aspect or a key application, something that we do to get the number of terms in a given sigma. We take top minus bottom, we add 1. As a matter of rule, guys. As a matter of rule. Let me just go back. Okay, you will remember there we had in this question, we said write the sum of the first 20 terms. So our assumption is that the number of terms is 20. Can we actually verify that using what we have here? What is 20 minus 1? So if we say 20 minus 1, then we add 1. What's 20 minus 1? It's 19. What's 19 plus 1? It is 20. So indeed, the number of terms is as we had been asked. Right? And our sigma is 100% correct if you take into consideration the idea that we said top minus bottom. What's 20 minus 1? It's 19. We then add 1. That is 20. So what's the number of terms? It's the first 20 terms, as we see here. Okay, I hope that makes sense. So coming back here, I first found out what the first 3 terms in the series is. Okay. Then 2, I found the number of terms in terms of n. How? N minus 3. Then we do what? We add 1. We get an expression of what? If we add the like terms, we get n minus 2. That is the expression. Okay. Okay. Then, very, very important. We can now use a specific formula. But I want you guys to note something here. So note something very, very important. Okay. Do you remember, guys, that when we take this n and we substitute in the place of k, what does this give us, guys? When we take this n and we substitute here in the expression, substituting this top number gives us the what? What does it give us? If we substitute the bottom number, we know it gives us the first term in the series. Substituting the top number, what does that give us? What does it give us, guys? If we substitute this top, obviously this is in terms of n at the moment, but if we had the specific value, if you take this value, substitute it here, what do we actually get when we substitute this here at the top? If by substituting this value of 3 here, we get the first value of the series, by substituting the top number here, what do we get in the series? Yes, we get the last term. We get the last value in the series. Thank you so much. Okay, so please then take note of what I'm going to do now. I can then say, identify the formula. Sn is equal to n over 2 into 2a plus n minus 1 into d, close that bracket. Okay, or I could use this formula. Okay, yeah, okay. Now please take note, and please take very important note of what I'm just about to do now. So if I use this formula, remember Sn is going to actually be what, guys? The number of terms, which is in terms of n, it's n minus 2. So that means Sn minus 2 in brackets is actually equal to 189. Are we together? Then I'm going to, in this formula, write this expression on the left, equate it to 189. Okay, so take note what I'm going to do. All right, I'm going to take the n minus 2. Remember, the formula says n over 2 into 2a plus n minus 1 into d, but now I have equal to 189. Don't forget that. So because the number of terms is n minus 2, it means that in the place of n, I'm going to have n minus 2 over what? Over 2. Okay, a, what is a? A is the first term. So let me write down what my a value and my d value is, because in the series 2 plus 3 plus 4, a is equal to, what is a equal to, guys? Tell me what a and d is. Let me give you guys in the comment section an opportunity to let me know what a and d are. This is my series 2 plus 3 plus 4. So what is a and what is d? So that I can have values to substitute in my formula for the series. What is a? What is the value of a? And what is the value of d? Okay, thank you, Annie. Annie is very much alive. I can imagine people are probably like being overwhelmed by sleep. A is 2. Thank you, Annie. And then what is d, Annie? I think Annie is the one that is going to be responding most, even for the next one. What is d then? Remember, this is the series 2 plus 3 plus 4. So what is d? Thank you. Aini, you're saying D is -1. Be careful. Remember, T2 minus T1. What's 3 minus 2? What's 4 minus 3? Remember, we are subtracting T2 T2 minus T1. So we say 3, that's positive, minus positive 2. So what's 3 minus 2? And what's 4 minus 3? And so it goes. Okay, be careful there. So D is 1. Okay, D is equal to 1. Very careful. Be very circumspect there. All right, you don't want to be messing up and saying T1 minus T2. Hey, imagine. Or saying T3 minus T2. That's where the chips, they fall. Okay. Okay, no problem. So 2 times 1. No, not 2 times 1. What was A, guys? A was 2. So 2 times, in the place of A, we write 2. Plus n minus 1 will become n minus 2. We substitute in the place of n we write n minus 2, followed by -1. Then the D, what is D? D is 1, equal to 189. Solving for n here is going to be very straightforward, really, to be honest. Okay, yeah. So n, we substituted the number of terms, n minus 2. A, we substituted 2. D, we substituted 1. Now let's simplify. Okay, that's where you see if people know their simplification. 2 times 2 is 4. Remember, word mess, bed mess, board mess. Okay, brackets multiply and all of that stuff. So 2 times 2 is 4. That's fine. Plus, here, if we distribute the 1, nothing changes, but we add the like terms inside the bracket, we are going to get n minus 3, which is equal to 189. 4 minus 3 there, 1 plus n minus 2 over 2 equal to 189. Okay, this is multiplied to that. So if I'm going to get rid of the 2 here, that's this side, I'm going to multiply by 2 both left and right, because all of this is one term. So if I'm going to multiply by this 2, that means the 2 and the 2, they cancel out. What I do on the left, if I multiply by 2, I'm going to do at the right. So 189, I just need from you guys to tell me what 189 times 2 is in the comment section. But this side, I'm going to be left with n minus 2 into 1 plus n. Whereas on the other side, you tell me what's 189 times 2. Whilst you find that out, I'm going to FOIL what I have there so that I can figure out what I get on the left. What's 189 times 2, guys? I need you to help me out with that. What 189 times 2 is. Thank you, Sir Opulence 378. I'm trusting in you, Sir Opulence, that you are right. Then FOIL, what's n times 1? That's n. N times n, that's n squared. Minus 2 times 1, negative 2. Negative 2 times positive n, negative 2n. When you multiply, guys, remember that you multiply the sign, the number, the letter. I repeat, n times 1 is n. You take this n, you multiply it with 1. You take the very same n, you multiply it by positive n. N times 1 is n. N times n, you keep the base n, you add the exponents, it's n squared. Okay, then you take the negative 2, you multiply it by 1. You first start with the sign, negative times a positive, negative. You move on to the number, 2 times 1 is 2. There's no letters, so you end there. Then you take negative 2, you multiply it by positive n. Start with the sign, negative times a positive, negative. 2 times 1, that's 2, and then n next door. Minus 378 is equal to 0. I think now you can actually write this equation in quadratic form. Okay, So n squared leads the way. You add the like terms, n minus 2n. What's n minus 2n? That's negative n. Then what's minus 2 minus 378? Negative 2 minus 378, that gives you, let's see what it gives you. Let's see in the comment section what you guys say. What's negative 2 minus 378? Negative 2 minus 378 is... Okay, thank you, Annie. Annie is very much alert and awake. Thank you. Negative 380. Then from here, you can actually solve the quadratic equation. And really and truly, the easiest way is to use the quadratic formula, because you may not necessarily know what the factors of negative 380 will be. The ones that you will basically multiply together. When you multiply them, you get negative 380. When you add them, you get negative 1. So knowing that maybe some of you may not be in the position of knowing such, quadratic formula helps out a lot. So all you do is you simply say n. Be very careful, don't say x, because you are dealing with a n here. N is equal to minus b plus minus the square root of b squared minus 4ac over 2a, negative minus minus 1 plus minus b squared, that's negative 1 squared minus 4 into 1 brackets negative 380 over 2 times 1. And all you do is you grab this calculator and you punch everything that you see there. Minus 1 brackets minus 1. Close the bracket. Say plus to begin. You put the square root. You put the bracket. You put negative 1. You close the bracket. You square it. You minus the 4. You put the bracket. You close the bracket. You put the 1. You open another one. You put minus 380. You close that bracket. You go downstairs. You say 2 times 1. You say equal. You get an answer. When there's a plus first. When there's a plus first, n is 20. Or let's change it. Go back to that fraction. We use our cursors. We go up. We go back. Yababona ban. I win. Yababona ban. I win. Back. There we have it. Plus. You remove the plus. You put the minus sign. Remember, you have in your formula, you have plus minus. So the plus was already taken care of. You change the plus. You change it to minus, so that you can see what the minus, what answer the minus will deliver. Negative 19. So n is equal to negative 19. Voila. But remember, what do we want here? We want n. And that n is the value we substitute at the top. Okay. So it's no ways that that value will be negative. So we say n cannot be negative 19. That n can only be 20. Okay. Does that make sense? N is 20. So all in all, we were able to figure out the value of n. Okay. Because remember, that is the value we substitute. You know? Can't be negative 19, it has to be 20. This is one way of doing this question. All right, one way of doing the question. Okay, any questions from those who have been watching me closely, doing what I'm doing? Any questions in particular? Okay, because I want to reveal the second way. All right, that remember I had written Sn is equal to n over 2 into a plus l as well, as a possible way of doing this. Okay, and remember, if you take this n, you substitute it in the place of k, you can get the last term, but you are going to get the last term in terms of n. So that means the last term, if you take the n, you substitute it here, k minus 1, n minus 1. It means that L is going to be n minus 1. So let us write Sn minus 2, because of course the number of terms is still n minus 2. Okay, then we are going to equate it to 189, but using this formula. So let's turn over the page. We are going to now substitute in the place of n. Okay, this is another approach. N minus 2 over 2. Then we write a here. What's a plus L? The a value is going to be 2. Okay, the a value is here, it's 2. The L value, the last term, we substituted, remember, just now, I told you, you take what's at the top, you substitute in the expression, you will get the last term of your series, which is in terms of n, the last term is n minus 1. So let's go ahead and write in the place of L, n minus 1. We make that equal to 189. Now let us solve for n, because this is another way of solving for n, using this time the formula n over 2 into a plus L. Yeah, okay. Yeah, no, it's fine. It's fine that your minds are resting. But yeah, I think you have gotten your chance to comment. Let me remove your comments now. Thank you. Really appreciate your views. But remember, your views are not helpful here. So please go and rest some more, guys, and allow those who are here to learn, continue to learn. Okay. So here we are, guys. N minus 2 over 2 into 2 plus brackets n minus 1, close brackets equal to 189. So let us solve this one. Seems like we can solve here as well. Inside 2 plus, we remove the bracket, n minus 1. We get rid of this 2. We multiply by 2 in the numerator. What we do on the left, we do where? On the right. This 2 and this 2 cancel. We are left with n minus 2 into 2 minus 1. That gives you n plus 1, which is equal to what? 189 times 2 is 378. Guys, if you look at this left hand, if this at what I've done here, you see what I'm doing here is exactly what I ended up having done this side. N minus 2, n minus 2, n plus 1. This is 1 plus n. It's the same thing as n plus 1. 378, 378. All in all, it's going to lead me to the very same answer that I got this side. And I used another approach. What was that approach? Were you guys listening? Right? The approach used is one of understanding that in my sigma, this here represents the number that I substitute into the given nth term to get the first term. The top value of variable represents that particular number of variable that I substitute to get the last term in my series. So using this formula, I could solve for n by, of course, first finding the series by substituting 3 and its consecutive values, getting the series, at least for the first 3 terms. Then I establish the number of terms by taking top minus bottom and adding to 1. The expression in terms of n for the number of terms is n minus 2, which is what I'm going to substitute in the place of n minus 2 to find the sum of those number of terms. And after I'm done, what do I do, guys? I go ahead, I either substitute in this formula, find n, or I can substitute in this formula where I have my last term and find the value of n, and I should be able to find it either way. Okay, right. So that is that. Okay, wonderfully and beautifully done. Okay, are we still, do we have people that are still alive here? I do realize it's 1 a.m. in the morning, but look at me, I'm pushing. We are pushing, you know, in the midst of sleep and other things. Are we still around? Do I still have people who are still here? Annie is still around there with the beautiful hand. Annie, like, but what time does it seem like your body will probably shut down? Like, just give me a tentative time so that I can kind of like, see when I can possibly stop the live. But yeah, I still have tons of energy. Literally, guys, I think I could teach until 5 a.m. in the morning. I'm not even lying. All right. This is no joke. I'm not joking with you guys when I say this. So let me just finish this off for the sake of those that n times n is n squared, n times positive 1, positive n, minus 2 times n is negative 2n, and then negative 2 times positive 1 is negative 2. That's all equal to 378. And then we get n squared minus n, negative 2 minus 378. That gives us n squared minus n minus 380. Okay, and the same thing I did here where I used the formula. Guys, remember, n is the variable. Don't make the mistake, my good people, of saying x is equal to, because remember, you are dealing with the subject n, so it must then suit what you have. All right, subject n, so we say n is equal to, not x is equal to. Still the same quadratic formula, we substitute there. And all in all, our answer will basically be the same. N is equal to 20 or n is equal to negative 19. But we cancel out because we can't have n being negative 19. N is 20. All right. Yeah. And so it makes sense, right? It makes perfect sense because we wanted the value of n, and it is therefore n which is positive. Okay. Yeah, so we are bringing back the algebra as well simultaneously. The reason why I love sequence and series being the first topic is that it helps us to also rekindle the flame as far as our algebra is concerned for question 1, how to solve quadratic equations. There are some questions that require you to use inequalities to solve and other things, so it brings back your knowledge of grade 11 so that you can actually remind yourself also of how to do certain things. Okay, right, let's move on to this question. Okay, I think now you guys are having a very good idea of sigma and the usage of sigma, okay, and what certain things actually mean. Look at this one. Suppose p plus 3p and p minus 2 are the first 3 terms of a geometric what? Series. Suppose, guys, suppose that p plus 3, p and p minus 2 are the first 3 terms of a geometric series. Calculate the value of p for 3 marks. Okay, do we have an idea what we would have to do here? Okay, p plus 3, p and p minus 2 are the first 3 terms of a geometric series. Calculate the value of p for 3 marks. So what do we do here, guys? What relationship do we utilize in order to find the value of P? All right, that's what the first question is requiring us to find, the value of P. How do we find the value of P? If the given series P plus 3, P and P minus 2 are the first three terms of a geometric, we've been told what type of series it is. It's geometric. So if it's geometric, what is the relationship that we should utilize in order to calculate the value of P? What are we going to do here, guys? Any ideas? 3 marks. So a geometric series is unique because it has a what, guys? Geometric series as well as a geometric sequence has a, what is the defining feature, the fundamental building block of what a geometric series entails? Okay, so we know that for a geometric series the ratio is constant. P plus 3 is the first term, this is the second term, that's the third term. So what we are going to do is we are going to get that relationship T2 divided by T1, which is equal to T3 divided by T2. We're going to use that relationship, the relationship of the constant ratio, to set up an equation. Set up an equation whereby we are going to solve for P. Okay, use the ratio relationship to set up an equation. So there we have it, P plus 3, that's term 1, that's term 2, that's term 3. So the relationship says T2, that means P over term 1, P plus 3 is equal to what? T3, what's T3? P minus 2 over T2, which is P. Okay, then all we do is we cross multiply. We can cross multiply, or we can use the concept of the lowest common denominator, right? Remember, guys, that in the denominator there are restrictions, things that P cannot be, because remember, the minute P is those values, then it will mean that the equation in its entirety is undefined. So we quickly, whenever we have a fraction equation, we quickly establish what are the restrictions. Okay, so P cannot be what, guys? For this fraction, what value can P not be? Because if it is that, then it will mean that we have a denominator that is there. And here for this fraction, what can P not actually be? We can't have P be that, because remember, guys, division by 0, okay, means that our entire equation and its fraction is undefined. So we can't have 0 here, we can't have 0 being there. So we say P cannot be 0 firstly here. Also we say P, if we look at this particular denominator, P cannot be -3. We can't have P being 0, and we can't have P being -3. Those are restrictive measures we take to ensure that we don't get an equation that is undefined because of having these P values. So we're going to be on the lookout that our answer, whenever it proposes that these are answers, we quickly nullify or remove those answers because of those restrictions. So let us cross multiply now. This P you multiply with that guy, and this P minus 3 we multiply with that guy. So we say P minus 2 into P plus 3. Let's go. What's P times P? P squared. Then we FOIL this side. P times P is P squared. P times +3 is +3P. Minus 2 times P is -2P. and then negative 2 times positive 3 is negative 6. Okay, then we add like terms, transpose all of those terms, p squared, take this p squared over, minus p squared minus 3p plus 2p equal to negative 6. Keep the constant term that side because I can see that the quadratic are going to be removed. P squared minus p squared is 0. Negative 3p plus 2p is negative p, which is equal to negative 6. But since this is a coefficient negative, we divide both sides by negative 1. So that means p is equal to 6. Does this fight against any of these values that are restrictions? No, it doesn't. So our value of p is 6. That's what p is. P is equal to 6. Finished. Straightforward, no problems, to the point. That is our answer. Okay. P is equal to positive 6. As smooth as we can go. That is the value of p. All right. Rods. Yeah. All right. Hopefully that is fine and good then for our grade 12s there, and we are good. Let's move on to the next question. Calculate the sum. Look at this. The sum to infinity of the series. Okay. Now, remember guys, in order for us to really have the sum to infinity of a series calculated, we need to first establish if the series converges. All right, and in order to successfully do that, let's go back to p, to the original series, and substitute the 6 there. So we have 6 plus 3, we have 6, we have 6 minus 2. Better yet, 9, 6, 6 minus 2. 6 minus 2. Okay. Okay. Is this? Yeah, what we had now. P plus 3. So that's 6 plus 3. Yeah. For real? For real. Okay. And just to confirm one more time, p over p plus 3, p minus 2 over p times p is p squared, p plus 3 into p minus 2. What's p times p is p squared, p times 3, 3p, minus 2 times p, negative 2p. Then that's negative 6. Then what we did, we transposed the p squared, transposed the positive 3p, transposed the negative 2p, we left the negative 6. We added all the like terms, we got negative p is equal to negative 6, p is equal to 6. Then ultimately we got 6 plus 3, p is 6, and then 6 minus 2, that's 4. So that's 9, 6, 4. And now they're asking us to actually do what? Calculate the sum to infinity of the series. So yes, we want to establish something here. 369 246. So r is 2/3, and this 2/3, guys, is definitely a value that is between -1 and 1. That means since r is 2/3, the series converges. Okay, this r is 2/3. If you want to find out what 2/3 actually is, there it is, guys. 2/3 in decimal form is 0.66666. That is a value that is between -1 and 1. That means this series does what? It converges. Because whenever our constant ratio exhibits greater than -1 but less than 1, which is 2/3 is a value that is like that, it means that the series converges. And do you know what? It means that we can calculate, therefore, the sum to infinity, which is given by this formula. Sum to infinity is equal to a/1 minus r. Sum to infinity is equal to a/1 minus r. What is a and what is r? What is the value of a, guys, in this series? So please, guys, it's not a sequence, it's a series, so it must behave as such. 9 plus 6 plus 4, that is a series. Okay, sorry, guys, because it does say series. So if it's a series, we must make sure that it exhibits such behavior that a series would exhibit. So my question then is 9 plus 6 plus 4. All right, what is the first term? What is the value of a here? I'm sure you guys can see that the value of a is 9. Then what is the value of r? It's 2/3. So a is 9, r is 2/3. So then we go to the formula that we have when we want to calculate the sum to infinity. Guys, please, the condition that must be met is that when we want to calculate the sum to infinity, it must first hold that the constant ratio exhibits a value that is between -1 and 1, because that means that the series converges, right? So when a series converges, that sets a beautiful condition for us to be able to calculate the sum to infinity. Sum to infinity cannot be calculated unless the series converges. So constant ratio must be between -1 and 1. So now we can go ahead and calculate the sum to infinity. A 9/1 minus 2/3. Then you go ahead and you solve this. You can actually just put all of this in a calculator and really not stress yourself a lot, by trying to do a lot of things all at once. 9 divided by 1 minus 2/3. Let's close that bracket. There we have it. Sum to infinity, K27 Brayaga. K27 Brayaga. Njaga. K27. Okay, sum to infinity. Okay. Do you want to take a look at the question one more time that I just looked at? Because it's a nice question. You are given firstly a series with variables, and then they ask you that these are the first 3 terms, calculate the value of p. All right, when you calculate the value of p, you are using grade 12, your constant ratio concept, to actually set up an equation. All right, as we did have here, you're using your constant ratio concept to set up an equation whereby you can solve for your variable p. Okay, so you set it up, the equation, then you cross multiply. All right, And I also insisted that you write down your restriction so that you know what values of p should you be avoiding. Why? Because remember, guys, we can't have a 0 in the denominator in a fraction. So for instance, this p, it means p cannot be 0, because the minute we have 0 here, it means that the entire fraction is undefined. The minute we have -3 in the place of this p, remember -3 plus 3 will lead us to 0 in the denominator. So we quickly flush out the values that will lead to an undefined state. Okay, then what do? We cross multiply, we solve for p, right? And the steps are very clear. P times p, p squared, p plus 3 into p minus 2. You FOIL this, right? You transpose, you add and subtract like terms. Linear equation is the result. You solve for p, you get p is equal to 6. And then you go ahead, go to the original values, substitute 6 plus 3 is 9, that's your first term. In the place of p, you write 6, that's your second term. 6 minus 2 is 4, that's your third term. So 9 plus 6 plus 4, that is your series. And then you calculate your constant ratio, because here they want the sum to infinity of the series. In order for you to be able to calculate the sum to infinity, you need to first establish, is this series a converging series? How do you know that a series is converging? If its constant ratio is actually a value between -1 and 1. So for instance, 6 divided by 9 gives you 2/3, just as 4 divided by 6 gives you 2/3. That's a constant ratio of 2/3, which is a value that is greater than -1 but less than 1. So we say that the series converges, and therefore we can now calculate the sum to infinity. The formula for sum to infinity is simply a over 1 minus r. What does the a stand for? First term. What does the r stand for? Your constant ratio. You substitute that, you solve for the sum to infinity, you get a value of 27. Done and dusted. Not a problem. All right, calculator, guys, you substitute, use your calculator, you get the answer, you get out of there, you collect full marks. Do you see? You collect full marks. All right, make sense? I hope it makes sense, guys. I hope it makes sense. Okay. Let us not not get marks because we failed. All right, let's look at this question. Consider the following series. There it is. Look at the series, guys. Look at it. 3 into 3 minus 2x plus 3 into 3 minus 2x to the power 2 plus 3 into 3x into 3 minus 2x to the power 3 plus, and there we have the dots to signify that this pattern continues. Exponent 1, exponent 2, exponent 3, the 3, the 3, the 3, the 3 minus 2x, the 3 minus 2x, the 3 minus 2x. The only difference is that there's a 1 exponent, 2 exponent, 3 exponent. The next one would have 3 minus 2x in brackets. So here they're saying find the values of x for which the series will converge. Find the what? The values of what? Of x for which the what? The series will what? Will converge. We need the values of x for which the series will converge. A series, guys, converges when what? R is greater than -1 but less than 1. That's how a series converges. It converges when R is greater than -1 but less than 1. So let us come here and first find what the value of R is in terms of x. That's your step number 1. Find R in terms of x. Step number 1, find R in terms of x. R is T2 divided by T1. That's how you calculate R. T2 divided by T1. Okay, we are already told, consider the following series All right, and already, okay, we are like, okay, t2 divided by t1, 3 over 3 minus 2x, the whole thing squared, over 3 into 3 minus 2x. The relationship between the numerator and the denominator, we can see 3 cancel, 1, 1. We cancel the 3 minus 2x, there's one of them. The 3 minus 2x, there's two of them. What gets left at the top? We get left with only one 3 minus 2x. Okay, but remember, this 3 and this 3, they leave us with 1 and 1. So the division of this and that leaves us with 3 minus 2x as the final answer. Okay, you could do the same thing here. If you divide t3 and you divide it by t2, it will lead you to the same answer. 3 and 3, they cancel. 3 minus 2x, there's 3 of them. 3 minus 2x, there's 2 of them. So if we cancel, 2 of them go for both top and bottom, but at the top we are left with only one 3 minus 2x. So you see, guys, that r, however you want to look at it, gives you 3 minus 2x. Okay, then 2, the condition of converging series. For a series to converge, the value of r must be between -1 and 1. In other words, r must be greater than -1 but less than 1. So we are going to now substitute in here this value of r. Substitute it in there. So we get formed as a result what we call, in grade 10 we did this, a compound inequality. Okay, that was the last time we officially did an inequality of this nature. It was in grade 10. Grade 10 level, you guys looked at compound inequalities and you solved compound inequalities. Okay, so we are back there again. We are back in grade 10. Okay, in grade 11 we learned how to solve quadratic inequalities, and that will serve its purpose in many topics that we do in grade 12. But here, when they ask you for which values, the values of x for which a series will converge, it will converge, guys, if that expression is greater than -1 but less than 1. So we place that expression in the place of r. Then we solve for x. Okay, I want someone who is saying I am very lost to say so that I can clarify any confusion that they might have. Are we still together? Are we still flowing in the same direction? Are we still kind of like, are we here? Do we get it? Are we lost? Is there confusion? Where is the confusion, if there's any? Are we good? Do you have a question? Do you want to double tap on the screen for me so that the live fluidity can continue to flow? Are you still here? Way delayed. Well, Presh, most you are going to always, I guess you always sign up to getting the live lesson when it's uploaded onto the channel. So this will be no different. I'll upload this there. Okay, just checking some, just doing exam type questions for sequence and series, so that at least there is comfortability. Okay, no one is raising anything. So to now solve the compound inequality, okay, grade 10, remember, we want at the end to have x isolated in the middle. Currently 3 is in the way, -2x is in the way. So the first thing we are going to do, we are going to get rid of this 3. It is positive. So to get rid of it, we subtract another 3 from it. But if you are going to subtract a 3 in the middle, it means you are going to subtract a 3 on the right. You are going to also subtract a 3 on the left. 3 was positive, so we subtracted a 3. So that means what we did here, we are going to have to do here and there. So what's 1 minus 3x? Negative 1 minus 3x, negative 4. 3 minus 3, bye-bye, negative, bye-bye 3. We are left with negative 2x alone. Then 1 minus 3, negative 2. Okay. Next step, get rid of the negative 2. But what relationship does negative 2 have with x? It's multiplied to x. How do you get rid of something that's multiplied? You use the inverse operation of multiply, which is divide. So what do? We divide by who? By negative 2. But what you do there, you do everywhere. Divide by negative 2 here, divide by negative 2 there. Okay, now the only thing is, guys, all right, if you decide to show this division explicitly, then you must actually change the sign immediately during the course of showing the explicit change. You must change. You see this inequality sign is facing, you make it face this direction. All right, you would do that in the midst of dividing by something that is negative. Guys, division by something negative leads to a change in your inequality sign. Division by something negative leads to a change in your inequality sign. So if you show that division of negative, let the inequality sign begin to change exactly at that stage. Okay. Final answer, 2x1. So then when you write it properly, 1, the mouth is opened towards x, let it continue being opened. It's opened towards x, let it continue being opened. It's open towards 2. So now we have a proper order: your small number this side, your big number on the other side. So x is truly greater than 1 but less than 2. X is greater than 1 but less than 2. These, guys, are the values of x, okay, for which what? The values of x for which the series will do what? Will converge. It will converge when x is between 1 and 2. That's when the series will converge. It will converge if x is between 1 and 2. It can't be 1, it can't be 2, but it must be in between 1 and 2. The series will then converge nicely because it means the value of r, as long as x is between 1 and 2, it means that the value of r will also be what? Will also between -1 and 1. Therefore, that will make the series converge. Okay? Okay. Yeah. So common question, common exam question, this one. All right. And all you need to do when they ask you this question, it simply means, firstly, you need to find r in terms of x by using your constant ratio formula. You find r in terms of that specific variable. Then after that, you substitute the expression in terms of x in the inequality. R is greater than -1 but less than 1. And then you solve for who? For x, using what? The concept that you learned in grade 10 of what? Of compound inequalities. And compound inequalities, really, guys, step by step, you can see how easy it is to actually solve a compound inequality. Okay. Yeah. It's happening. We are cooking, guys. We're cooking with gas. We started out with quadratic sequence. We cooked. Hey, we cooked. We also reminded each other about functions and its relatability, how a quadratic sequence relates to a quadratic function, where it is the same and where it isn't. We looked at series, guys. We looked at a arithmetic series, specifically how to find the nth term in an arithmetic series, how to find the sum of specific terms in a series, how to write the sum in sigma notation, how to actually present something in sigma notation. Guys, we did that. Hey, we did that today. Today was just the fun in the sun, if you ask me. Okay? That's what we did today. Then we kind of a bit wrapped it up with let's just back check here. Track. Then we looked at how to calculate the value of n if we are given a sigma sum in actual fact. Okay, some steps that we need to take into consideration, especially finding that value of n. We are given the nth, the general term. We are given what the sum actually equals to. We are given the value that we need to substitute to get the first term, but we need to find the value that we substitute to get the last term, which is an unknown. And we basically was simple in approaching this question. One of two ways was presented, and we did quite well. We were able to use our understanding of solving a quadratic equation using the quadratic formula and getting the answer very easily. Then we looked at a geometric series, in terms of variables there, how to find the value of p using our understanding of geometric constant ratio, how to find the sum to infinity of a series, the importance of using r, that is between -1 and 1, establishing first that a series converges in order to be able to find the sum to infinity. Okay, formula which we have, a over 1 minus r, which is the formula we use to calculate the sum to infinity, which was quite straightforward. Yeah, and then we ended off in how to find the value of x if a series converges. And once again, very simply put, really and truly, we are utilizing the constant ratio concept to simplify a algebraic expression. And this guys this is like grade 10. This is grade 10, really and truly simplifying an algebraic fraction, and then the substitution into this compound inequality, which leads to a compound inequality to solve for x. Another grade 10 concept that we are utilizing in grade 12. So guys, all in all, the concepts learned in earlier grades, very crucial and critical. Okay, I think I'm going to hold it right there for this particular session. I think it was very meaty. It was very worthwhile. I hope you guys enjoyed it. Right? I don't know why I always get a bit sad when I don't know why, guys. Maybe I'm just gift oriented. I think I love gifts, and it's sad when if an entire live session I do it and there's no gift at all. Like I almost feel like, was the lesson that bad? Like, did no one get touched to the extent that they thought to themselves, let me go down to my gift gallery and just at least send this guy, even if it's an ice cream or a rose, whatever. So I don't know, but I'm not saying that you should do it, but I'm just saying, hey, I don't know, it kind of makes me feel some type of way, in a way. But don't get me wrong, that's just me. I'm just being human right now, and I'm just sharing my heart. But nonetheless, guys, I hope the lesson was good and beneficial. Please, if you missed anything, remember I do upload the lesson onto the YT page. The link is in my bio. You can always obviously rewatch it in your own time. Take it one step at a time. Really take it in. You don't have to watch the entire video all at once. You can watch it in segments, and in that way you can actually like internalize at your own pace and get things inside. Okay, so that's it for today. I will be continuing on. As you can see, guys, my book is full of other questions that are waiting to be answered. We'll actually look at these other exam type questions that are coming up. We even have a nice, I think there's like some word problems as well that are here, that are more story based, because there are story based problems that we do get in sequence and series that are not necessarily like your straightforward type of questions. So we'll be looking at those, and these are just exam type questions, guys. Exam type questions. There we have an amphitheater type question as well, you see. Yeah, so we're going to be looking at more questions tomorrow. Thank you so much, guys. So I'll see you guys, I think, again later on at night, tomorrow night. Yeah, if it's not at 9, guys, then it's at 10. If it's not at 10, it's later on after 10. I'm a night with the grade 12s, guys. It's night stuff. It's cross night stuff. Okay, you're welcome, Cassidy. Thank you so much. Jesus loves you. Thank you so much for that as well. I love the message that's on your profile picture, Cassidy Keating. You are welcome, and thank you for joining. I do realize that some of you are probably gone Tongoland. It's like all sorts of snoring is taking place. It's unattended, but yeah, I want to thank you guys for joining in. Precious, thank you so much. Precious, you're always so precious joining in the lives. I really appreciate your presence and contribution. Luandle, always, forever and always, my brother. Queen, oh yes, Queen of Queens. Queen is always also here. Thank you so much as well for joining in and being here. Anyi, comment section was ablaze because of you, especially like towards, I could see after 12 people were gone, but you were still actively commenting in the comment section. Really appreciate you. Bontle, awesome. BMA, Rex, opulence. Thank you, buddy. You've been a sport. Trochidi, my moderator, always looking out. I know it's not in grade 12, but definitely always here when you can be here. Really appreciate your presence. Sizwile, you've got a graduate here. Big system shows are when this Tikila, Tehofatso, Sonabila Static Touch, Mandlagazi, Maveti, Mati, Knowledge, Tabiso, Shikar, Singh, and Otando, Mr. Excluse. I wonder what inference does that have? Abraham's Redao, Shavi, Mr. Kruger, Orajo, Jacob Mapanga, Jose Spencer, Ribese, and the dreadful paper bag. Wow, the dreadful paper bag is got a dreadful paper bag. Definitely, it's even that color. It's Alwandle all the way to Kevin, Delani Madela, Sabza the Small, Ngelema Roma Insizwa, T-Bone, Bindi, Spider, Dion, Defender, Joanne Fernandez, we've got Liberty, we've got Edu, we've got Self King, we've got Loy, Kanyama, Zwi Detroit, R, Mandla Makubela, TK Jr., we've got Mac L, we've got Ngiti Liza, we've got Oyana Sia, and Letelo, Letelo, and Timonanas. And thank you for all the follows, guys. Very much appreciated the follows, and thank you for the support, and thank you for being here. Thank you. Let me love and leave you. This is your host of Maths is a Game. Let's play to win, guys. We play to win. We win all the time. We win. Let's play, because Maths is a game. Cheers.